In this video, we are going to take a look at what's called the contingency table. So this is where you have a table with basically two factors that you're trying to see if there is a relationship between them. So here is the party affiliation and whether you favor or oppose increasing electric vehicle sales in United States. Okay, so the first thing we do is we go ahead and add up the rows and the columns totals. So which is what I'm gonna do right now. Luckily, there are not that many. Okay. Now we're gonna do the same thing with the columns. And always check your work a couple of times just to make sure. And then once you get the row columns totals, then you can get what we call the grand total, which is like the overall total. So you can do that by either adding the rows, the row totals, or the column totals. Both of the answers should be the same. So when you look at the numbers, that would always be something that I would recommend doing before moving on, is to see if these two numbers, or not necessarily two, however many rows you've got, equal to that total, but also these two totals, or more if you have more columns, then they're all equal to that overall grand total. So that should work. And it does in this case. Okay, which you can check just if you don't believe me. You got 2 or 3. Okay. So the next question says, what is the probability that the respondent that is randomly selected is a Democrat? So here what you want is look at the total number of Democrats and divide it by the total number of people surveyed. This is what we call favorable over total. So what is the total number of Democrats? Well, that would be 101. And then you are dividing this by the grand total, which is 203. Now, it asks you to round to 4 decimal places, which you can do just using the command round. So just copy that and 4 decimals. So that would be the answer. Okay, the next question says, what is the probability that the respondent that is randomly selected is in favor of rules that aim to expand EV sales? Okay, so if we look at the total number of people who are in favor, that would be 85. And you dividing that by, again, the grand total in the table by 203, which is the total number of people surveyed. So we can go ahead and round this again to 4 decimal places and copy paste that here. Now, this next question gets people a little bit confused. Now, this is just saying, what is the chance that the respondent is a Democrat who is in favor of rules aimed at dramatically increasing EV sales? So here we have to look at the intersection or overlap of people who are Democrats and they also favor the rules. So when we look at the table, let's look at the Democrats. So that would be all of these, right? And see where they overlap with the favor. So the favor is this part. So we can see that they overlap right here. So that number should again be divided by the grand total in the table. So total number of people who are Democrats in favor, which is 68. And then we divide that by the grand total and again round this to actually 4 decimal places. All right, so the next question is what we call an inclusion-exclusion principle. So we're saying, what's the chance that someone is a Democrat or somebody who is in favor? So here we can do two things. First of all, you can look in the table and look at Democrats. So that would be these. And also people who are in favor. So there, well, the 68 we already counted, so we're not going to double count. So we're also going to add these 13. So if you add these three numbers and then divide them by 2 or 3, that could be the right answer. But the inclusion-exclusion principle says that you can actually just add the chance that you are a Democrat, then add the chance that you are also in favor, and then subtract the overlap so you don't double count it. So let's go ahead and do that. Okay, and that would give us the same thing. So if we were to add I'm just going to show you. If you were to add 33, 68, 17, and then divide that by 2 or 3, you should get exactly the same thing. So this is just a slight rounding difference, but overall you'll get the same exact thing. Okay, now the last two questions are what we call conditional probabilities. So how do we know that the question is conditional? So when you read the question, it says, what's the chance the respondent is in favor given that? So when you hear this given that a respondent is a Democrat, that tells you this is conditional. So what you do is you look at the given part. Like, what is the given part? So go to the table and highlight the given part. So imagine you are a Democrat because you are given that you are a Democrat. So you are now inside the Democrats. You don't see anything else. You are now inside these people. How many of them are in favor? Well, that would be 68. But this time it's not out of the total, two or three, but the total in the condition. And the total in the condition is 101. So in this case, this would be 68 divided by 101. So notice how the bottom is not the same, because now you know you are a Democrat and you can't get out of that. Okay, you're like inside that universe. Okay, so let's put that in here. Now, how is that different to the next question? The next question says, what's the chance that the respondent is Democrat given that? So again, this is conditional, but what is now the condition? That the respondent is in favor. So now you look in your table and find the condition. What is in favor? Well, that would be everybody here. How many of those people are Democrats? Well, that would be 68. But again, you are not dividing this by the grand total. You are dividing it by the total in the condition, because you are now inside the in favor crowd. Okay, so this would be 68 divided by 85. Notice how the top is the same, but the bottom is not, because the condition is not the same. Okay, so in this case, that would be 0.8.